Okay, where were we, friends? In the last episode, we restructured our database. So all the to-dos are in a sub-collection called to-dos under every user. So the database path goes users, user ID, to-dos, to-dos ID. You got it? Okay, good. Everything's fine and dandy. But now it's actually possible for someone to go into the database and read the to-dos of other users. We don't want that. We don't want to allow that. Let me demonstrate how that could work. So here I have the same to-do list app opened on two windows. One logged in as user 1, one logged in as user 2. So user 1 adds buy potato 1. I'll just put a 1 there to indicate that this is from user 1. Buy fish 1. User 1 has two things in the to-do list. And for user 2, let's go buy dog 2. And this guy is being very adventurous, buy cat 2. Seems good. We're not seeing any to-dos overlapped here. We're not seeing any problems. Everything seems fine. But in the database, if we go and get the user ID of user 2 here, and if we copy this, and in our code where we put user.uid, if we replace this and put the ID of user 2, then you will see that user 1 is able to read the data of user 2. Save, refresh. Here you see, we're on user 1, but because I took the user ID of user 2 and requested for user 2's to do instead, I for some reason can read user 2's to do's. And that's wrong. That's wrong. Why is this happening? Why does Firebase allow this to happen? This is where Firestore rules comes in. When you initialize the Firebase project in the beginning, you may have noticed this file here, Firestore rules. If you open it, you'll see that right now the rules here are really loose. Let's break it down. What the rules here is basically saying is we allow read and write to every document in the database as long as the request time is before the 30th of April 2023. Okay, this is the only rule we have. As long as we're requesting before this date, we can read every document in the database. I could push this forward to whatever date I want and it would still be really loose. This is not what we want. So what we want to do is to make sure that the person requesting this data actually owns this data. How can we do that? We would write it like this. Let's break it down. We allow read and write to all the documents inside the user/user ID path, right? If the request.auth is not equal to null, which means that the person requesting this data is authenticated, okay? Request.auth not equal to null, right? We want this person to be authenticated and we want to make sure that this person's UID matches the user ID in the path. What path? This path. This path right here. See? Users, user ID, to-dos, to-do ID. We want to make sure that in the rules, the user ID matches the user ID in the path. If we go back here and refresh the page, we'll see, cool, we don't see user 2's data anymore. That's cool. But also, if we open the console, we'll see Firebase threw an error and the error says permission denied. If we did it here, refresh, it would be fine. It still works fine. User 2 can still access user 2's data because this data belongs to user 2. So let me just go back to the file here and change this back to user ID, saying that, okay, user 1 can only read user 1's data. And if I come back to the page, we see that I can see user 1's data again. That's been a very quick summary of the Firestore rules. I'll link the documentation down below. These rules can get pretty complicated at times, especially when you have a lot of documents, a lot of collections, and a lot of users of different roles. Then you have to kind of differentiate what kind of user can access what kind of documents. So yeah, go play around with it a bit and good luck. Take care. Goodbye.